Welcome back, guys. Hope you're doing great. It's Vetri here. Well, basically, in this series of video, we're gonna break down some common toughest senior level interview questions which has been frequently asked in JavaScript interviews. So basically, we're gonna write some mission codes and we're gonna break down some mission codes and how to answer them in the interviews and how to explain the scores in an efficient way, right? So in this series of videos, you will learn a few commonly asked interview questions, right? And the most toughest senior level interview questions. So if you're watching this channel for the very first time, hit the like and subscribe button, and that will encourage to come up with a more concept, something like this, and along with the project-based concepts as well as. So without wasting your time, let's get started. So this is the very first question which we are going to discuss about. If you want this particular question, click the link in the description below. You can see the GitHub uh, link, click it, and you can see the code and you can see the explanation about this code as well as. So let's break down this interview questions. So this is actually a very strong interview senior level question. It basically tests the how the you control the asynchronous operations and the concurrency levels and the closures and the promises orchestrations. Okay, so what we're going to do is we're going to break it down the way you should explain it in the interview. Okay, so first you need to understand what problem does this solve, this particular program, what problem does this solve. So this implements a custom map limit utility function, right? Similar to the libraries like Bluebird. So it processes an array with a limited concurrencies instead of running everything at once. Okay, so let me give you an example. So assume that you have an array, something like this: 1, 2, 3, 4, 5. Okay, and basically we're going to limit this is the array we have, and we're going to have the limit which is going to be 2. Okay, so what we are going to do is we go, instead of running all these things in a single instance like one by one index, what we're going to do is we're going to run it in a parallelly by using the limit. So assume that you are be having the limit as 2. So every time, instead of accessing one element at a time, we're going to access 2 different elements. Okay, so instead of running all these things in a 5 seconds, we're going to make sure to run it in the 3 seconds. So we're going to optimize the time by enhancing its performance. That's this program is all about. Okay, so only 2 asynchronous operations run at the same time, not all the 5. Okay, so how we can explain it in the interview in a single line. So basically we can say we create a pool of workers based on the limit, and each worker picks tasks from the array until the tasks are completed. Okay, until all the tasks are completed. Okay, so let's break this down. So you can see this very first function we have, function delay. So basically that's the function which simulates the asynchronous work. It's getting the function parameter as the milliseconds which we are going to supply from outside, and we are returning a promise, a resolved promise, and we are making sure to return the value to wait sometimes until that milliseconds and then return the resolved value. Simulates the asynchronous work, right? But in a real cases, here you can see the functions like API calls or batch processing or upload queues, something like that. But in this case, we're going to keep this one to simulate the asynchronous process. Okay, then we're going to create these map limit function which takes the three different parameters, which is going to be the array as the first one, then the limit, the concurrency limit, then it's going to take the asynchronous function as a parameter, complete function. And inside the function we have these 2 different lines of code where we are creating the results. But instead of creating it as an empty array, we are making sure that is a pre-allocated array. The reason why we are pre-allocating the array with the exact same length of the array whatever we are receiving inside as a parameter, we have to maintain the order in order to push the value. So instead of the reason why we are maintaining the order is to avoid the unnecessary push, because that leads to the mess up ordering of the asynchronous functions, right? That's the reason. Then we are initializing the global shared index, which is going to be I equals to 0. That's a shared index. This is the this shared across all the workers which we are about to create. Okay, and basically it acts as the task pointer because we have to point out which task is being currently active and all those stuffs. All right, then we have this worker function, right? This is the worker function which we have. So basically this is the place the multiple workers were accessing the shared index, right? And each workers grab the index, grab the next index. The reason why we need to grab the next index because we are planning to access it simultaneously to get the parallel actions. If the current index is this, then we need to access the second index as well as. So that's what's happening over here. Okay, each worker grab the next task using I++. Okay, so that avoids the duplicate work. So basically this is the place where we have the closure and we have the shared mutable state. All right, and this is the point where we are executing the asynchronous task. So based on the shared index, the common index, so we are supplying the value to the asynchronous function. We're going to perform that asynchronous task. If we get the result based on the index which we accessed in the value, the array which we are supplied, and we are going to store it in the exact same order as we in the results as well as. So we're going to perform an asynchronous task. If the task executed successfully, store the result in that same index, or else store the null as in the same index. Okay, so we can maintain the common order. So the reason why we are handling it in this way, this is kind of similar to the promise.all settled. So we have two different functions in the promise.all and promise.all settled. Basically, the difference between the promise.all and the promise.all settled, we have to understand it. Promise.all handles the asynchronous tasks. Think about it, you are supplying three different asynchronous operations to that function. If any one of the functions failed but other two is successfully executed and it's collected the data back, if any one of them is failed, all it stops the execution completely, so we lost the data for the previously executed two different asynchronous operations as well as. On the other hand, if you are using all settled, even though all the asynchronous tasks are not completed successfully, if any one of them is failed, it doesn't matter, it will collect back the data of the other two and it will handle the one which is not successfully executed. So that's the difference between the promise.all and the promise.all settled as well as. Okay, so this kind of simulates the promise.all settled. We are executing an asynchronous operation. If that operation is successfully finished, we are storing the result in that index. If not, we are simply storing the null value in that index. Okay, and now we have to create the workers and we have to make sure all the workers should accomplish their task completely. Nothing should be failed. So based on the array, we are creating an array of workers based on the limit. That's the important. Based on the limit, we are creating the workers. And all the workers that needs to be successfully completed, that's why we wrapped it inside the promise.all. It needs to be resolved. Okay, that's why we are using this. And then it needs to be returned that results in the exact same order. Okay, so this is the place where we are trying to test it, right? So let me show you how does it run. So if I execute this program, this is the one which you are going to get 2, 4, 6, 8, 10. But since we are using an array, it's stored the values in the index, so the result may look so similar. What's the difference? But when you're if we talk about the time complexities over here, instead of running all these indexes in 5 seconds, because we are using the delay time as 1000 milliseconds, which means one index is going to take the 1000 seconds, so 1 second, which means it's going to access 5 seconds. It's going to take 5 seconds for 5 different indexes. So since we made this as the map limit and using the concurrency limit as 2, it's going to access the 2 different indexes parallelly and it's going to perform the task. So instead of accessing the single indexes in 1 second delay time, we're going to access 2 different things. So if you want to execute all these 5 elements in an array, it's going to take 5 seconds overall by running normally by using the for loop and all those stuff. But in this perspective, we will take only 3 seconds. So compared to that, the time complexity is completely reduced. So on the 0th seconds, because the time complexity is going to be O power n, so on the 0 seconds, it's going to access the first 2 index 1 and 2. And on the second, which means the first second is going to access the 3 and 4, and on the last second it's going to access this value. So then that's the output you will get. So this is how we are accessing. So for these two values it's going to be 1 second, and for these two values it's going to be 1 second, and for this value it's going to be 1 second. Okay, this is all about the this program. Okay, so on the interview perspective, what are the key concepts that the interviewers are looking for? So you should explain you should explicitly mention these key points, as well as concurrency control, and you need to explain the event loop behavior. Then you need to explain the shared state, the I value. Then how do we achieve the closure and promise orchestrations, or how we did it over there, and how the orders are being preserved. These are the key points that you need to explain in this question, not just explain the program. These are the key points that you need to cover. So let me give you the key points. These are the key points that you need to cover. Okay, don't forget to mention all these key points. Then anyways, when you are explaining these questions in the interview might ask some follow-up questions as well as. So we have to prepare for the follow-up questions as well as. So let's talk about the follow-up questions. So what if the limit is equals to 1? If the limit is equals to 1, of course the answer, what you have to answer, it becomes a sequential execution, just like a normal iterations, right? So we don't have to use the promise, all those stuffs. We can simply use the asynchronous function with the await. We don't need to go for this. Okay, so the reason why we choose the concurrency limit in order to limit the parallel, because we need to execute the array indexes parallelly. So that's the reason we choose this method. I'm sorry. So then the second question, does this preserve the order? Of course, we are preserving the order. Yes. You have to, because this is the yes or no question. Yes, we are preserving the order because the results are stored using the indexes, right? And you have to point out where we are storing the results by using this results. This is the place where we are storing the results. And the second question, the third most question, which is going to be, can we stop executions on the first failure? Think about it. If any asynchronous task is failed, we have to stop the execution. If you want to do that, instead of using the try and catch, right, we have to go for promise.all rejected state. If it is rejected, we have to stop it. The question is very simple. Can we stop? Of course we can stop. Just we have to modify this line of code. Okay. And where this line of codes are useful in real cases? That's the next question. Of course, we're going to use this in a real case scenarios like the API rate limiting, scrapping, and batch processing, and upload queues. These are some places, common places where we use this kind of approach. Okay. And then last question, what happens if asynchronous function becomes a synchronous function? Instead of using asynchronous function, what happens if I use the synchronous function? That's the question. So the strong answer is going to be, it still works, but await wraps it into a promise. It's going to wrap it into a promise. If you're using a synchronous operation, this particular await is going to wrap it into a promise. What promise? As a resolved promise, not a rejected one, as a resolved one. It's going to work, but await is going to wrap the asynchronous, wrap that function into a resolved promise. That's it. That's the answer. Okay. So I hope explain this question and explain this code in a briefly, and I hope you guys understand. If you have any trouble understanding this program, you can point out that question in the comment section and we're happy to help you out. And if you want this code, you can click the link in the description below. You can open the GitHub and you can access the question, and you can access the detailed brief explanation about this question as well as. So we're going to upload this as a series. So you will learn the commonly asked interview questions, and you can learn the few every day we're going to upload any single questions by explaining it, or we're going to upload it in the multiple questions as well as. Along with this, we're going to upload some tech videos as well as on the project based videos as well as. So stay tuned. A lot of things are coming up in the coming days. So I hope you guys are fired up, right? Because I'm fired up, because that's what we are going to bring it to this channel from the next upcoming days. Okay, so hit the like and subscribe button, and if you have any questions or any suggestions, please leave it in the comment section, and we're happy to help you out. And I will see you all in the next video then.